Somebody else just joined. All right, guys. So the plan for today is we're going to start looking at the practice final unless people have specific questions. Does anyone have questions from homework, or it could be, so we can open it wide open. We could do recent stuff. We could do chapter 1 questions. I mean, we're getting ready for the final today and tomorrow. So if nobody really has any questions, I'm just sort of going to start going one by one through the practice final. It's really up to you guys. If nobody's asking anything, then the floor is yours. You can ask any question from the entire semester. Isn't that crazy? Okay. Right. So fair enough. Maybe we'll just start looking at the practice final. Are you guys doing okay? We're almost there, right? Are you guys just sort of like, why can't it be done? Why is it just almost done? No? All right.
It's just early for me.
I understand. It's always early when we do this. Okay, so here's the practice final. And of course, it's up on Canvas, if you didn't know. So if nobody has any questions, my backup plan is just to sort of go step by step through the practice final. So if you want to pull up your own copy, go to Canvas, pull it up. You know, it's one of the first modules, the practice final. So I'll give you a minute if you want to do that. Okay. All right. So what I'm going to do then, this is, I don't know, we'll see how this works. I don't know if anybody has tried any of these out on the practice final exam yet? Has anybody actually looked at this yet? Okay. All right. So let's see. First off, let me do something. Make it all about me. There we go. Let's see. You guys are all very tired. Are you guys working on a lot of final projects? Is that what it is?
Oh yeah.
Final essays, final projects,
final screenplay.
Screenplay, dude.
Screenwriting class.
That's awesome.
Yeah.
That's awesome. I took creative writing and nonfiction writing. I actually like to write. So we did like not a full-fledged screenplay, but we actually wrote like a little play and then we had to act it out. And that was neat. And this was at Grossmont. I can take classes for $1 since I work there. And I haven't been able to do it because I don't have any time. Anyway, sorry. So let me do this. Make sure you guys can find what I'm talking about. So if you go to modules, if you go right here, very first module, practice final. Bang. Oh yeah, I've got to, all right, that's right. Anyway, sorry. I've got my schedule for next week. I'm going to post this on Canvas, but yeah, does everybody understand how next week is going to work? What's happening on Monday next week?
Monday is
Memorial Day. Memorial Day, no classes.
There you go. Monday's a holiday.
Mm-hmm.
Tuesday, all next week. So tomorrow is the last class.
Mm-hmm.
Understand, everybody. This week is the last week of classes. Next week is finals. All schedules change. Do you understand?
Yeah.
You really want to make sure your teacher has told you what time your final exam is, because it's not going to be exactly the same as the normal start time. So for example, our final exam, man, I've got it right here. It's on the syllabus. It's on the homework sheet. It's also right here. Our final starts at 9:25, which is awesome. Because if you join at the normal time of 9, you're early. And that's the way you want to be, if anything, for a final, right? I highly recommend that you log in before 9:25, just to make sure everything's working on your end. You guys all with me? Because here's what's going to happen. Now, everybody remember that the final is going to be like the midterm. You're going to need your camera on. What I'm going to do also is I'm going to lock the meeting about 10 minutes into the class time, because if you're not there within 10 minutes of class time, I have no idea if you've already accessed the final and maybe started doing stuff off camera on the final. So does that make sense, everybody? So you need to make sure you can be here on time. The camera's working, right? Just like the midterm. Okay, all right. So let me know if there's any questions about how that's going to work. All right. I will have office hours starting at 8 a.m. on Tuesday. So I will put a Zoom link up and remind you that I'll be in there starting at 8. So 8 to 9:20. So we got an hour and 20 minutes of office hours on right before our final. Okay, so that's good. So let's see. Think, Jeff. What else? Oh yeah. So you pull up the practice final. Since there's no specific questions, we're just going to start going through the practice final. So go ahead and get that bad boy up here. So let me share it a different way. There we go. Can you see my practice final?
Yes.
Yeah. Are you like me and you just can't wait until you don't have to have that question asked by so many teachers? Like, can you see what I'm showing you right now? Can you see what I'm showing you? So I'm so sick of Zoom and also. All right. Who remembers? Anybody remember Venn diagrams? Good old Venn diagrams. What do they look like? Give me a rough description of what a Venn diagram looks like.
2 big circles with like a little weird overlap in the middle.
Possibly. So 2, maybe more, where they might overlap. And they should be in a box. So you make a universe. The box is your universe. And then you've got things broken up into at least 2 groups, right? So you can have the group of people that like bagels and the group of people that like pickles. Or the people that like both, bagels and pickles. Yes, I am one of them. So then there would be overlap with all the people that like onions. I'm sorry, where'd onions come from? Bagels and pickles. I think I'm trying to put together a sandwich in my mind. All right. So stay with me now. Who remembers? So let's go ahead. How many groups do I have in number 1? How many main groups do I describe?
3.
Okay, maybe. But so there's people that drive the car and people that use public transportation.
2.
So there's 2 main groups, right? You could argue there's like 4 because you do or don't do both. But anyway, there's 2 main groups that I directly describe, correct? So this is going to be a case, like Caitlin said, 2 circles. So go ahead. Who remembers what are they going to overlap? Is there going to be an overlap? The 2 circles?
Inside
Yes,
each
there are
other.
people.
Mhm.
Yes, because there's people that use both.
Yeah.
Jeff, you're not making it big enough. All right, let me start over. Let me make this thing big. Barf. So here's my universe. Universe. The universe looks like a box. Here's people that drive. And then here's people that do public transportation. Not physical therapy, public transportation. Go ahead and try to fill that in. And in case you have any trouble, can somebody remember what's the most important number to start with?
25, because that's what
Yes.
both.
Start from the inside and go out. Today is the day to ask questions for damn sure, right? If at any point you have no idea what's happening or how we do something, ask. Well, today and tomorrow. not just today, today and tomorrow. All right, so this is a you get it or you don't kind of problem. Where does 25 go?
In the middle.
Middle.
Middle, I like it, because that's where the people do both. How many total have to be in the drive circle?
163.
There's got to be 163 total in the drive circle. How many do I already have in the drive circle?
163 minus 25.
So I already have 25. So then
Minus.
Wafa knew my next question. How do you figure out what goes here? 163 minus 25. Let that make sense. Doesn't there have to be 163 in the drive circle? Aren't there already 25 in there? So the one number I'm going to put here, what's
138.
Yeah, 138. So isn't there 163 in there? That makes total sense. Yay. All right, so how to do the same thing for the, now I keep thinking this is physical therapy. Do the same thing for public transportation.
15.
Yeah, it's supposed to be 40 total. I've already got 25, so I'm gonna put 15 here. Yeah, there, a little line. Yeah, thank you. All right. And then there is a number that should go right here. How many are not in either circle?
Okay, we can add 138 plus 25 plus 15.
So far, I got 138 plus 25 plus 15. Let's see, that is 40 plus 138 is 178. So I got 178 people in the circles.
250 minus
Good.
the total.
178. 250 minus 178. So I got 178 in the circles and 250 total. So how many is outside the circles? Well, the rest.
72.
72. What are these 72 people? Does somebody help me describe these 72 people somehow?
People who neither drive or use public transportation to get to school.
I like it. So what
They
might they
walk.
do? Huh?
Walk to
They could
school.
walk, they could run, they could have one of those giant drones that you can actually ride on. No, I don't think that. Sorry. They just don't drive or use public transportation. Right? I like it. So how many of the students only drive their own car?
138.
138. Good. I know 163 drive the car, but 25 of them also use public transportation sometimes. So 138 only drive their own car. I like it. So for those people, I guess if their car's broken down, they just don't go. Of course, now let me say this. This is obviously, I created, well, this was back before pandemic times, right? Now everybody gets to school the same way at the moment. How many of the students don't use either form of transportation? Well, we just identified that, right?
72.
72. Yeah, so the whole thing is drawing this picture correctly. If you draw the picture correctly, put the numbers in there, then the rest of the questions should be really easy. Now, what if I had said instead, like I did on a quiz, what's the probability that I pick somebody who only drives their own car? Only drives. Oh God, Jeff, what language is that? What's the probability that I would pick somebody who only drives their own car?
1/138.
No, nope. I did not say if I choose from people that drive their own car, what's the probability that I pick Fred? So that would be one Fred out of 138 that drive their own car. Now be careful. So how many people total are there?
250.
250.
Out of those 250, how many match what I'm looking for?
Oh,
138.
Yes. Yes. Probabilities are the number that match what I'm looking for divided by the total number. right? That's how you make a probability. Because real quick, if I had 4 black marbles and 1 million white marbles, and I said, what's the probability I pick a black marble? And you say 1/4. Does that make any sense? Is there a 25% chance that I pick one of the 4 black marbles out of the 1,000,004 marbles? No, that doesn't make any sense. Do you guys with me? Are you guys with me? So the
Yes.
bottom has always got to be the total number of things it could be. And if I pick a marble out of this bag, there's not only 4 marbles in the bag, there's 1,000,004 marbles in the bag. I understand. All right. Sorry, somebody was chatting to me. Okay. So is number 1 okay? Does that come back to you now, the Venn diagram stuff?
Yeah.
Yes, thank you.
And I've done this before where I changed it into a probability question. What was that on? Was that on the last? That was on the
In the midterm.
midterm. That's right. Okay. So number 2, I'm sorry, the symbol for some reason didn't really, but you guys see what that means, right?
Square root.
Yeah, thank you. Well, symbol just didn't want to fully make itself. Don't say anything. Think about this for a second. I think we did this not too long ago. Don't say anything. Oh, it's a little evil the way I said this, but you should be able to tell me between what 2 numbers it is, right? But then I ask for a little bit more than that. So can somebody tell me between what 2 numbers would the square root of 30 sit?
Can I say?
Yeah, that's why I asked. I
Yeah.
think somebody just said, go ahead.
Yeah. 25 and 36.
So that's not what I asked, but that does get us in the direction. So square root of 30 is between square root of 25. And so the square root of 30 is between 5 and 6, which I think I heard somebody else say.
Yeah.
All right. Now I ask for a little bit more than that. Who thinks they know? Is it closer to 5 or closer to 6? What do you think?
It's closer to 5.
All right. Did you do it, or are you truly guessing? Somebody have their calculator handy? What is the square root of 30?
It's like 5.47 something.
Ooh, it's almost right in the middle. 5.47 something.
5.4772255575.
All right, keep going, please. No, right, I'm sorry. It would keep going forever, so let's not do it. Okay, cool. So that's a little bit evil, but it's sort of a opinion. So if you said 6 and it's actually closer to 5, but your reasoning made sense, then I would be okay with it. All right. So normally I would ask between what 2 numbers is that square root. Now, obviously, if it was the square root of 35, right? If I said square root of 35, that one should be really close to 6 because 35 is really, really close to 36, right? This is a little evil because 30 is almost directly between 25 and 36, right? Right. Now this one should feel kind of
Excuse me,
familiar.
Professor.
Good.
Sorry, I have a question. My big problem is explain your reasoning. Though I don't know how to explain.
Oh, well, this pretty much explains most of the reasoning.
Okay, I don't know to write down the sentences, something like that.
What? Sorry?
Should I write down the sentences about that or not?
So the neat thing is, a sentence is not the only way to explain your reasoning.
Okay.
Yeah.
Math.
So see, math is really useful. So this explains my reasoning. Now I could say, if I wanted to say which number, and you said 5, for those people who guessed 5, what was your reasoning for that? Why did you say 5?
Because 5 is closer than 6.
I don't understand what that means. What do you mean 5 is closer than 6?
Oh, 5 is closer to 30 than 6.
5 is closer to 30 than 6? No. Do you mean 25 is closer to 30 than 36? That I could agree
Yes.
with. Okay. So that would be decent reasoning. It would be a little incorrect because the square root's not a straight line, but it would still be good reasoning. So I don't know if that's why people said 5, because 25 is closer to 30 than 36 is, just by a little bit. I don't know if that's why people said that.
That's why I said that.
Okay, I like it. I like it. So, I mean, it's good reasoning. It's a bit fallacious because the square root is not a straight line, but it's perfectly fine reasoning. Fine, Jeff? Yes, perfectly fine reasoning. Okay. Is that okay for this problem here? What really sucks is if I ask a question like this and people don't address it at all. I mean, that's a quick way to lose a decent number of points. Okay. So what about, does this one sound very familiar? This is actually from before. More recently, we did stuff like this based on exponential stuff. Can you guys see why this is not really an exponential thing? Am I talking about growth? Am I talking about change? Living
No,
on a budget. His budget is $1,500. So I say anywhere that he's getting any kind of raises. No, right? And then he's spending this much money each month. Do I say anything about how, if that's changing? No. So this is not a changing problem. This one is actually from way earlier in the semester. Just what are percentages? How do they work? So he's got rent. He's got food. He's got bills, other bills. Boy, oh boy. And he's got fun. All right, there we go. Thank God. It's just the general fun. I like that. So take a minute and can you figure out how much he's spending each month? How much he's spending each month on Josh? How much he's spending each month on those? Do you think he lives in San Diego? Maybe, but I would say no. In fact, what is 1/4 of that? This might be me in my first apartment. My first apartment. I think my rent in my first apartment was $326 a month or something. Can you guys imagine that?
yeah, that's really crazy. It's
Sorry,
Rent-
Tristan's like, that's nice. That's nice for you.
no. Do you
No, I don't
want
blame
the
you.
right answer?
I don't blame you. All right, so which one are you going to tell me?
Rent.
All right, how'd you calculate it?
So 1,500 times 0.25.
I like it. So 25% of means multiply 1,500. Kick ass.
And you're gonna kind of do you're gonna do 1,500 times 0.20 for the next one, right? You're just gonna keep
What's
using
the answer to this one?
375.
All right, 375. Is everybody with us so far? Okay, I'll take that as a yes. And then, like you said, you just keep going. 1,500.
300.
Food is 20%, so that's 0.2. $300. I like it.
And then what is the 15%?
Yeah, so then 15%, 0.15.
$225.
1,500, 225. Is everybody cool?
And then fun 30% is one sec, $450.
Good. I like it. So how much is he saving? Did I even ask that question? No. Can you guys see how much he's saving?
What'd you say? How much is
How
he
much is he
saving?
saving? Yeah.
You would add up all of the money he's spending, and then whatever's left would, I guess, be his savings, right?
Good, subtract it from 1,500. You
Yeah.
could also say 25, 20, 15, and 30 is 90% total. So 10% is being saved because he's not spending it. Yeah. Okay. All right. Whatever mystical city the person lives
It's
in.
gonna be $150.
Good. Yeah, he's saving 150 bucks. All right. So I wish I would have asked that. That would have been a good question to ask. How much is he saving? Well, you know what he's spending. So whatever's left must be what he's saving. And then I ask you to create a bar chart. Not a histogram, a bar chart, because the data is not numerical. The data is rent, food, bills, fun. Right, so now I just got to figure out what scale for the money here. Can somebody figure out a good scale to represent all this money amount? What's a good scale to use? All right, that's bugging me. I gotta make that a straight line. Can I make that a straight line? Sure, somewhat. Can somebody help me?
200.
All right, so if we get, well, 200, 400, 600, we could probably do a little bit better than that.
We can use the 50s.
50, 50, 100, 150, 200, 250, 3, yeah, what about 150?
Okay.
That's kind of nice. But yeah, the 50 would work, but with my little tiny space that I gave myself, I'm going to do 150. But you know, if you give yourself more room, you could do 50. That's fine. Right. So now I can go, rent is going to go up to 375. So about there, probably not about there. It's a little too high. Oh, well, too bad. And then food is going to go to 300. That's nice. Bills go to 225, which will be a little bit lower than that, Chuck. And then fun is 450. Bam. Big old fun bar. There we go. All right, so that's not too bad, right? So bar charts are nice. They're nowhere near as involved as histograms. So let's see, money spent, categories. All right, somebody chatting to me. Let's see. Why did you use 0.15 first? Oh, well, again, real quick, what's 2 times 7? Is that different than 7 times 2? Are they different? Does my question make sense? Somebody's
No,
multiplication, it doesn't matter what order you do it in. Personally, this makes more sense to me because it's as we say it, 15% of 1,500. I wrote these down this way because that's the way that Tristan said he did it, and that's mathematically it's fine. 25% of 1,500. I can write it that way if I want to. Yeah. So again, 6 times 8 is 8 times 6. It doesn't matter which one comes first. I personally like to write it like this because it matches with how we say it. 15% of 1,500. Math don't give a shit, right? Math is like, that's nice, human in your language. I don't care. Yeah. Okay, cool.
Professor,
Yes.
I have a question.
Yes.
I forgot, you told me before, but I forgot when we create a bar chat. I forgot why sometimes we have the space with them.
Okay.
But yeah.
You ready? Bar chart. Bar chart means this data here is not numerical. Does that make sense what I'm saying?
Yeah,
These are not numbers.
yeah, I remember.
Yeah. So they don't have a scale that they have to follow. So if there's a gap, it doesn't matter. This is all rent. This is all food. If I have numerical data and there's a gap, I need one more thing here. So if I have this and then I have this, that would mean that this is empty. That means something. So if it's not supposed to be empty, you better not have a gap there.
Okay, thank you.
You're welcome. So it's because of numbers create their own scale, which means an empty space means stuff missing. Here, this is not really a scale, it's just words. And they each get their own bar, and who cares, right? So bar charts are easier than histograms because of that. Okay, I like it. I like it. Okay. Now this next one, I didn't mean, somebody pointed out that this was confusing, and I'm really sorry, but I think I created this problem back when I had just gone to the, do you guys know there's a train museum in Balboa
Balboa
Park?
Park.
Yeah,
the
yeah.
Model train museum.
Yeah, and I think, well, this is a while back when I actually had, anyway, we were talking to the, to one of the people there, and they were talking about the scale, and they were like, oh, scale. So I looked it up later. I'm like, oh, that's what that means. And so I made a problem out of it. Yay. But then some people tell me that looks like it says 0 scale, and that freaked me out. I'm like, oh, I didn't, oh, shit. But O scale is something that model train people talk about, and it means it's a 1 inch is 4 feet. So like in real life, if two things are 4 feet apart, on my model, they would be 1 inch apart, right? That's what a model's for, is to take big distances and make them small, take big buildings and make them small, proportionally, right? So in the US, real train tracks have rails that are 4 foot 8 inches apart, on average, I guess. I don't know if I looked that up. I'm sorry if it's not right. Is everybody with me so far? So in reality, they're 4 feet 8 inches apart. And I want to know, how far apart would the rails be on a miniature train track using O scale, which means 1 inch to 4 feet. Oh, there's a couple little details here you got to be careful about. So listen to me. If they were exactly 4 feet apart in real life, how far apart would they be in the model? What does O scale say? What is O scale based on?
1 inches to 4 feet.
Good. So if they were 4 feet apart in real life, how far apart would they be on the miniature train track?
1 inch.
1 inch. Does everybody see what I'm saying? What if they were 8 feet apart in real life? How far apart would they be on the model?
2 inch.
2 inches. Does everybody see that? If 1 inch is 4 feet, 2 inches is 8 feet. So what is wrong with the way this is given to me right now? What's kind of wrong that I have to fix? What's the only thing I can work with? What's it got to be in real life? What does the units have to be in real life?
Feet.
Feet. And do I have pure feet?
No.
No. So what do I need to do with the 8 inches part?
Change it to feet.
Change it to feet. You guys with me? No,
Yes.
a little bit.
Yeah. A little bit.
A little bit. All right. So real quick. What if it was 13 feet in real life? What if a tree was 13 feet tall in real life? What would it look like on my model, on my
It would
miniature
be
track?
3 inches, a little bit over 3 inches.
I want to know exactly.
Okay.
And you're like, it's too bad.
Sorry.
Deal with not knowing.
I'll find it.
Watch this. 13 feet. How do I convert that? Hey, it's our little grid.
Oh no, not this thing. I'm terrified.
4 feet equal to 1 inch, right?
Yeah.
So horrifying about that. 13 divided by 4, which is what you did, isn't it?
Yeah.
Did you do 12 divided by 4 and say, well, 13 is just a little bigger? Well, now just do 13 divided by 4 to get the exact answer, right?
3.25.
There we go. So it'd be 3¼ inches apart on the model. I don't know if you guys are still with me out there, or if you ever were. Okay. So I know this is 4 feet, but I need to know 8 inches. I need to convert that to feet. So then I can do exactly what we did over here. I need 8 inches turned into feet. Now, you got to be really, no, this is such a lovely problem. I love this problem. I'm not going to use this. This is bullshit. This is going from real life to track, right? I'm not ready to go from real life to track yet. I'm still real life to real life. In real life, 8 inches is how many feet? Well, what would I put down here? I want to convert it to true feet. What would I put down here? You guys remember?
Inch.
Inches, because I want them to die.
Mhm.
Die. And up top, I would put feet. How many inches in a foot?
One.
Say again.
Four.
12.
12. I love it. We're not doing the track yet. We're not doing the miniature stuff yet. We're still in real life. So what's 8 divided by 12? Roughly.
0.6.
That's too rough. 0.67, right? It's 0.6666666. The evil decimal. All right. So now I can do exactly like we did here. So tell me, can somebody tell me 4 feet 8 inches is how many feet?
Four feet, 0.67
I just put it together. It's 4.67 feet.
feet.
Now I'm ready to go from real life to miniature track, right? So now I want to take this and do exactly like we did right here. In real life, I got feet, but I want to go to inches on the track. So how many inches and how many feet on the track? I want to convert from real life to track. How many feet in real life convert to how many inches on the track? You can do it. What's the conversion?
1 inch to 4 feet.
Yes, 1 inch to 4 feet. And now you just got to do wherever the hell that is. Let's see, Jeff, can you do it? 1 and 1/6. I think it's 1.17. No, I don't know.
Yeah, 1.1675.
Ooh. So we'll say 1.17 inches. So if it's 4 feet 8 inches apart in real life, it'll be 1.17. Now, why does that make sense? 4 feet is 1. Shouldn't 4 foot 8 just be a little more than 1 inch? If 4 feet turns into 1 inch, 4 feet 8 inches should turn into just a little more than 1 inch. That makes sense. I don't know if you guys get that. I love this problem.
Wait,
ahead.
sorry, Professor. I don't mean to
Sure.
interrupt you. I think I'm losing it a little bit.
I understand.
So 4 feet and 8 inches turns into 1.17 inches
On the track.
on the model. But what is the equation you're doing to find that out?
No equation. This is just the idea of conversion. So right here is what we did, just like we did here.
Yeah. So you took 4 point, that says 4.67 though.
It sure does. Of course it does.
Why? Sorry, why does it say that?
What do you think it should say?
4.8. Oh,
Ah,
never
okay,
mind.
let's try
Oh,
this.
I got it. Okay, I'm dumb.
It would only be
yeah.
0.8. No, you're not the only person thinking this. Sure. It would only be 0.8 if it was 8 inches out of 10.
Hmm.
But it's 8 inches out of 12, right?
Yes,
That's why we did 8
that's
divided
right.
by 12.
That's right. Okay.
Yeah. So if we had sort of like
Okay.
a metric like unit system, we would have 10 inches in a foot. That would be more like metric, wouldn't it?
Yes.
And then things would be that easy. That's why metric is so beautiful, because it's as easy as you want it to be. But we got the American system. And I can say that now. There used to be 3 countries, and now there's only us. We're the only country left on the face of the earth that doesn't use metric. I'll stop now. I'm sorry. I'm going off on a rant. All right. So it's a very good question. I love it. But it's because it's not out of 10. I like it.
Yeah, that makes total sense now. Okay.
So sort of like some people would say like an hour and 15 minutes should be 1.15 hours. Well, no, because 15 minutes is not out of 100 minutes. So of course it's not 0.15. It's the same thing. And I see that all the time. I like it. Okay. So a number only, I'll stop. I think you get the idea. Let's see. How much more? There's not too much more on this, is there? It's not very long. Okay, good. You're like, what's wrong? It's fine, Jeff. Let's just do this one here and then we'll call it a day. And then we'll pick up tomorrow with number 6. And maybe tomorrow you guys will have more general questions. We'll find out. So number 5, this sounds very familiar. We've done this several times this semester. Don't say anything yet. Just think about this. Why would a linear equation be appropriate given the data we see here? Don't say anything yet. So given this data, don't say anything yet. Why would it make sense that it's a linear relationship? Okay. Who's got the answer? Do you guys remember this? Do you guys remember this? Who's got the answer? Anybody? What does it take to be a linear relationship?
So it has to go up by the same amount every time.
Gotta
It
go
can't
up by the same amount?
compound.
Sorry?
It can't compound or else.
Yeah,
it's
it can't
going to be-
compound. It can't go up by a different amount each time.
Yeah.
Yeah. So how much does it go up by each time?
We're gonna subtract 88.47 from 68.97.
Well,
And
the other
then
way, but that's
we'll see if that's the same for the other one.
right. We gotta do all of them, or else it's, yeah, we gotta do all of them. I love it. So what do you guys get for that? What is the difference? How much did this go up by? Do you guys have calculators out there?
I'm doing it.
19.5.
19.5.
Yeah.
Now, if you add 19.5 to this, do you get here?
It's
Same thing.
Yeah.
107.9%.
Here and here, yeah, you can pretty much see that it's working fine. Yeah, okay. And by the way, what's really important is this also goes up by the same amount, correct? If either one of these went up by a different amount, that would be bad. But they both go up by the same step size, which means what remains constant? Oh, this is a little bit of a push. Let's see. Well, let me just say the word. Slope. Does the slope remain constant?
Yes, because it's a linear line.
Well, let's find it. Find the slope. How would you find the slope?
Sorry, I didn't mean to say that over the microphone.
But it's all good. So how do you find slope? What do you have to divide? You got to divide two things, right? You got to divide.
The rise and the
Y2
run.
minus
Good.
Y.
And we know it rises by 19.5, correct?
Mhm.
These are the Y's. Rise.
And the run is the miles.
So slope equals rise over run equals $19.5
Over 50.
over 50 miles. Now, what do you get when you divide those things? What do you get, Jeff? I don't know. I get 0.39.
Yeah.
Yep.
Woohoo! Look at me go. 0.39 what?
Miles per. Nope, it's
Dollars per.
dollars per mile.
Dollars per mile.
Okay.
Now, if this freaks you out, you could also say 39 cents per mile if you want to, right? Isn't it the same thing? Just don't say 0.39 cents. That is less than half a penny. We don't live in England where they have half pennies. I think they still do. I don't know. All right, so let's not use this formulation. Let's stick with dollars. So $39.39 per mile. What is this? Oh, I see. So that's the amount of money it costs just based on miles you go. How much does it cost just to be able to get into the car and drive it? How much does it cost just to be able to get into the car?
68.97.
Yes, I like it. So I kind of asked this question backwards. What's the y-intercept? Can somebody tell me? What's the, for any y-intercept, what does the x value have to be?
0.
0. Okay, so tell me what the y-intercept is.
68.97.
Okay, I'll accept that, but it's 0, 68.97. And explain what it means. We just did that, didn't we? It costs $68.97 just to get in. Boom, right? You haven't gone anywhere yet. It just costs that much to rent it, period, right? This must be a decent type of car. Has anybody ever rented a car before? I normally get like a tiny thing and save some money, but anyway, determine. All right, so now we have everything we need to be able to figure out the equation of the line. And in general, can somebody just tell me what is the equation of the line in general? Y equals. Anybody? Hello, hello.
mx plus b.
There we go. Okay, cool. So put that together. Don't say anything yet. What's the equation of this line? All right, tell me. What's M stand for? What does M stand for?
Slope.
The slope.
0.39.
That's right. Because math people, we don't know how to spell. So M stands for slope. So what's the slope? So I think somebody just said it.
0.39.
So 0.39x. And what's B stand for?
68.
Yeah, the Y piece of the y-intercept. I like it. Cheep, 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 cheep. Is there a way to check that to make sure we got it right?
You could take the Y's and X from every single one of them. And
Not every single one. We already know that this is linear.
yeah,
So all we have to really do is pick one. So if I pick like 100 as an input, the output better be 107.97, right?
yes.
So this is 39 plus 68.97, which is 107.97. Yay! So that's, you don't have to do that, but that's how you can check to make sure that you got the right answer. I actually went up for the input. I got the correct output. Okay. By the way, I never said anything about this, but I'm sure you guys have seen. You guys see my eyeball? I don't know if you can see it. It's all red, so I had my shot yesterday. Yay! So don't freak out. I'm not going insane. I could be going insane. Okay. So I'm going to leave the rest of this for tomorrow. I want to kind of, we can leave early a bit if you want to. If nobody has any specific questions at the moment. Oh, somebody's already left. I love it. Okay. I don't see any more questions. So you guys are free to go. I'll see you guys tomorrow. Come with questions. Be ready.
Yeah, we'll do.
Okay.
Thank you, Professor.
All right. Thank you so much, Professor.
Thank you.
Yeah.
So for D, just wondering,
Yeah.
does it have to be 68.97 when the y equals 0.39x plus 68.97? Could it be like
Yes.
88.47?
88. Oh, no,
No,
because
okay.
I
So
really
I
want you to get this.
Yeah.
This number has to be what I get when x is 0, because when x is 0, this piece
Oh.
goes away.
Oh, okay.
When x is 50, I get this. So there's no way this
Yeah.
could be 88, because then when I put a 50 here, it's not going to be 88 anymore. Yeah.
Okay.
That's why that number has to be the y-intercept number.
Okay. All right. Thank you.
Sure. See you tomorrow.